Hello everybody, welcome into another lesson. So today we are starting the analytical trigonometry side of the trigonometry unit. So in today's lesson we're going to simplify trigonometric expressions. So right here you have something like the cotangent of x times the sine of x. This can definitely be simplified. So what is the cotangent? That's the same as the cosine of x over the sine of x, and then you have that times the sine of x. Well, when you do that, your sines will cancel out and you're just left with the cosine of x. So this simplifies very nicely into the cosine of x. Alright, let's see. We have the cosine of angle beta times the tangent of angle beta. So we have the cosine of angle beta times the tangent of angle beta. So, of course, you have your cosine of beta. Now we could take that times the tangent. The tangent would be the sine of beta over the cosine of beta. So your cosines of beta are going to cancel out. This will simplify very nicely into the sine of beta. That should be your final answer, would end up being the sine of beta. Alright. We have the sine of theta times the quantity of the cosecant of theta minus the sine of theta. Well, we can definitely use the distributive property here to start simplifying this. So this would turn into the sine of theta cosecant of theta minus the sine squared of theta. Well, let's look at this first term, sine of theta times the cosecant of theta. So you'll have the sine of theta times 1 over the sine of theta, because the cosecant's the reciprocal of the sine, all that minus the sine squared of theta. Well, your sines will cancel out on the first term. You're now left with 1 minus the sine squared of theta. Well, 1 minus the sine squared of theta is the cosine squared of theta. So this simplifies into the cosine squared of theta. Alright, let's see. We have the secant squared of x times the quantity of 1 minus the sine squared of x. Well, let's use the distributive property again. This would turn into the secant squared of x minus the secant squared of x sine squared of x. Well, what do we get then? Well, secant squared of x, that's going to be, of course, 1 over the cosine squared of x. Then let's deal with the second term. Minus, now your secant squared of x is going to be 1 over the cosine squared of x times your sine squared of x. Well, let's look now at your second term. So you have 1 over cosine squared of x minus sine squared of x over cosine squared of x. Alright, well, you have the same common denominator. This turns into 1 minus the sine squared of x all over the cosine squared of x, but we could simplify this further. Your numerator, 1 minus sine squared, that just equals cosine squared of x all over the cosine squared of x, which would equal 1. So in the end, this should simplify into just the number 1. Alright, we have the cosecant of x divided by the cotangent of x. So the cosecant of x divided by the cotangent of x. Well, this is the same as 1 divided by the sine of x all over the cosine of x divided by the sine of x. So we end up with a complex fraction. So you invert and multiply, this would turn into 1 over the sine of x times the sine of x over the cosine of x. Your sines will cancel out. You would get 1 over the cosine of x, which is simply the secant of x. So this should simplify rather nicely into the secant of x. Alright, so now we have the secant of theta all over the cosecant of theta. Well, let's see here. So the secant is going to end up being 1 over the cosine of theta. All that divided by your cosecant, which is 1 over the sine of theta. Complex fraction, you just invert and multiply, so you'll have 1 over the cosine of theta times the sine of theta, which would end up giving you sine of theta divided by the cosine of theta. Well, sine over cosine ends up being tangent. So this would just simplify into the tangent of theta. Let's see, we have the secant of alpha times the sine of alpha all over the tangent of alpha. So this is going to be a good one. So let's look at these two terms. What's the secant? The secant is 1 over the cosine of alpha. Let's put that in parentheses here. Times, now the sine of alpha stays the sine of alpha, but in your denominator of the second term, tangent is going to be sine of alpha over cosine of alpha. So let's go ahead here now. We'll have 1 over the cosine of alpha times, now this will turn into a complex fraction. You would end up having the sine of alpha times the cosine of alpha all over the sine of alpha. Well, in your second term, notice your sines cancel. So you're literally left now with the cosine of alpha over the cosine of alpha, which would just give you 1. So this should end up simplifying into 1. Alright, so we have the tangent squared of theta all over the secant squared of theta. Well, there's actually a very nice way to simplify this. So tangent squared, if we remember the Pythagorean identity, so 1 plus tangent squared is secant squared. That actually means then that secant squared of theta minus 1 equals the tangent squared. So you can actually end up having secant squared of theta minus 1 all over the secant squared of theta. Now, if you look at this here, secant squared of theta divided by secant squared of theta is 1. Minus 1 over secant squared of theta, that'd be minus the cosine squared of theta. This would turn into 1 minus the cosine squared of theta, which would just end up being the sine squared of theta. So this should simplify into the sine squared of theta. Now here's a good one. You have the sine of pi all over 2 minus x times the cosecant of x. Well, that sine of pi over 2 minus x is a periodic identity. If we take pi over 2 minus x, it just turns into the cofunction of x. So sine of pi over 2 minus x would just turn into cosine of x times the cosecant of x. Alright, so cosine of x will stay the way it is, but what's the cosecant? Well, that's 1 over sine of x. You end up getting cosine over sine, which just turns into the cotangent of x. So the answer you should get is the cotangent of x. Alright, another periodic function, periodic identity. We have the cotangent of pi over 2 minus x times the cosine of x. Alright, so we have the cotangent of pi over 2 minus x times the cosine of x. Well, that cotangent of pi over 2 minus x, that's a periodic identity. That means this would become the tangent of x. So this would turn into the tangent of x times the cosine of x. Well, what's tangent? Tangent is the same as the sine of x over the cosine of x. You'll take that times the cosine of x. Now your cosines cancel out. You're literally just going to be left with the sine of x. So that's going to turn into the sine of x. Good one here. So we have the cosine squared of y divided by 1 minus the sine of y. Well, alright, so what is cosine squared? We know cosine squared plus sine squared equals 1, so 1 minus sine squared equals cosine squared. So this could turn into 1 minus the sine squared of y all over 1 minus the sine of y. Well, we can factor that 1 minus sine squared of y. This would turn into 1 plus the sine of y times 1 minus the sine of y all over that 1 minus the sine of y. And if you notice, your 1 minus sine of y is going to factor out. You should just be left with 1 plus the sine of y. So the answer you should get is 1 plus the sine of y. Alright, let's see. We have 1 over the cotangent squared of x plus 1. Well, that cotangent squared plus 1's a lesser used Pythagorean identity. Cotangent squared plus 1 actually turns out to be cosecant squared. So this is the same as 1 over the cosecant squared of x, which would just simply turn into the sine squared of x. So in the end, you should just get the sine squared of x. All right. So that was the starting basic simplifications. Now we're going to do some simplifications by factoring, which are especially useful when we go to solve trig equations a couple lessons from now. So you have the cotangent squared of x minus the cotangent squared of x cosine squared of x. And this looks pretty horrendous to start with. But just like in an algebra problem, you want to factor out the common terms. So let's factor out, definitely the cotangent squared of x is the common factor. This would factor into simply 1 minus the cosine squared of x. Well, now what is 1 minus cosine squared of x? That's the sine squared of x. So this would be cotangent squared of x times the sine squared of x. Alright, well, what's cotangent? That's going to be the cosine squared of x all over the sine squared of x. All that times the sine squared of x. And your sines cancel. You're just simply left with the cosine squared of x. That should be your final answer. Cosine squared of x. Alright. Next we have the secant squared of x, tangent squared of x, plus the secant squared of x. So we're going to simplify this by factoring. You definitely have a common secant squared of x you can factor out. This would turn into the secant squared of x times the quantity of the tangent squared of x plus 1. Well, what's tangent squared of x plus 1? That actually turns out to be another secant squared of x. So you'll end up getting the secant squared of x times the secant squared of x, which should just give you the secant to the fourth of x. So this would simplify into the secant to the fourth of x. Alright, so we have the cosine squared of x minus 4 all over cosine of x minus 2. Well, this isn't so bad. In the numerator, we have a difference of 2 squares. So this is going to factor into the cosine of x plus 2 times the cosine of x minus 2 all over that cosine of x minus 2. Well, the cosine of x minus 2's cancel out. You should just simply be left with the cosine of x plus 2. That should end up being your final answer, is the cosine of x plus 2. All right, let's see. We have the cosecant squared of x minus 1 all over the cosecant of x minus 1. Well, again, in the numerator we have a difference of two squares, so this would be the cosecant of x plus 1 times the quantity of the cosecant of x minus 1 all over that cosecant of x minus 1. Well, your cosecants of x minus 1 cancel out, and it should simplify down into the cosecant of x plus 1. All right, now here's a good one. We have the tangent to the fourth of x plus 2 times the tangent squared of x plus 1. So this definitely takes the form of a quadratic equation, only with trigonometry. This should simplify then into the tangent squared of x plus 1 squared. Which, what's the tangent squared of x plus 1? Well, that ends up being the secant squared of x to the second power, which should just end up giving you the secant to the fourth of x. So this should simplify rather nicely into the secant to the fourth of x. Alright, we have 1 minus 2 sine squared of x plus the sine to the fourth of x. Or, wait a minute. Yeah, that's right. Okay. So 1 minus 2 sine squared of x plus sine to the fourth of x. Another quadratic equation form. This would simplify into 1 minus the sine squared of x to the second power. Well, what's 1 minus sine squared? That just turns into cosine squared. So this would be the cosine squared of x to the second power, which would end up being the cosine to the fourth of x. So that should simplify into the cosine to the fourth of x. Alright, so we have the sine to the fourth of x minus the cosine to the fourth of x. So what's this going to look like? Well, this is going to look exactly like sine squared of x plus cosine squared of x times the quantity of the sine squared of x minus the cosine squared of x. Well, what is sine squared of x plus cosine squared of x? That's going to simply end up being 1. You get 1 times sine squared of x minus cosine squared of x, so you would actually just end up being left with sine squared of x minus cosine squared of x, and that's the best we could get. You could factor this further, but it's really not going to do you any good. You get sine of x plus cosine of x times sine of x minus cosine of x. That's really not going to benefit you to factor any further. Alright. Secant to the fourth of x minus the tangent to the fourth of x. Well, again, we definitely have a difference of two squares, so this would factor into the secant squared of x minus the tangent squared of x times the secant squared of x plus the tangent squared of x. Well, secant squared minus tangent squared just turns out to be 1. So this is just going to simplify into the secant squared of x plus the tangent squared of x. That would be your final answer, would be the secant squared of x plus the tangent squared of x. Alright, let's see. We have the cosecant cubed of x minus the cosecant squared of x minus the cosecant of x plus 1. So we have a third degree trig polynomial equation. So this should definitely factor by grouping. If you look at the first two terms, you have a common cosecant squared of x. Then you would take that times the cosecant of x minus 1. And then you can factor out a minus 1 on your second two terms. So that'd be minus 1 times the cosecant of x minus 1. Which this should turn into the cosecant squared of x minus 1 times the cosecant of x minus 1. Alright, so what is in fact cosecant squared of x minus 1? That's going to be cotangent squared of x. So this would turn into the cotangent squared of x times the cosecant of x minus 1. And can we really simplify this any further? Well, cotangent is going to be cosine over sine. I don't think it really simplifies much further. Not in a pretty way, at least. There's really a lot of ways you can simplify this, but this is just going to end up with cotangent squared of x times cosecant of x minus 1. And we have a very similar one here. We have the secant cubed of x minus the secant squared of x minus the secant of x plus 1. Another factoring by grouping. So if you look at your first two terms, you can factor out that secant squared of x. That'll be times the secant of x minus 1. Your second two terms, you can factor out a negative 1, so that'll be minus 1 times the secant of x minus 1. Well, this would factor then into the secant squared of x minus 1 times the secant of x minus 1. And what's the secant squared of x minus 1? That just turns into the tangent squared of x minus 1. Then you'd have that times the secant of x minus 1, which really doesn't simplify any further, so this is the best you could get, the tangent squared of x times secant of x minus 1. Alright, we even got some more operations here. Okay, so we're going to simplify by expanding now. So you have the sine of x plus the cosine of x, that quantity written to the second power. Well, this would end up being the sine squared of x plus 2 times the sine of x cosine of x plus the cosine squared of x. Well, what's sine squared plus cosine squared? That's 1. So you would end up getting 1 plus 2 sine of x cosine of x. Now, for now, we're just going to leave our answer like this, but in a few lessons, we're going to see that 2 sine of x cosine of x would actually turn into 1 plus the sine of 2x, because that 2 sine of x cosine of x will turn out to be a double angle formula for the sine of 2x, but we don't have to know that right now. It can just stay like this. Alright, let's see. We have the tangent of x plus the secant of x times the tangent of x minus the secant of x. Well, what's that going to simplify into? That'll end up being the tangent squared of x minus the secant squared of x. Alright, so we know 1 plus tangent is going to, 1 plus tangent squared is secant squared. So that would have to mean tangent squared minus secant squared would be -1. So out of all that work, that should just simplify into -1. Alright, let's see. Cosecant of x plus 1 times cosecant of x minus 1. Well, this should expand into cosecant squared of x minus 1. Well, we know 1 plus cotangent squared is cosecant squared, so this means cosecant squared minus 1 would end up being the cotangent squared. So this will be the cotangent squared of x. Alright. We have 5 minus 5 sine of x times 5 plus 5 sine of x. So let's FOIL this out. This should end up being 25 minus 25 sine squared of x. Well, now we can factor out a common 25. This should turn into 25 times 1 minus the sine squared of x. Well, what's 1 minus sine squared? That's the cosine squared. So this should just turn into 25 cosine squared of x. And that's what you would get, 25 cosine squared of x. Alright, so we have 1 all over 1 plus the cosine of x plus 1 all over 1 minus the cosine of x. Well, I think to start with, our goal is definitely going to be to get the same denominator. So this would turn into 1 minus the cosine of x plus 1 plus the cosine of x all over 1 plus cosine of x times 1 minus cosine of x. Well, the numerator is just going to simplify into 2. You'll end up with 2 all over 1 minus cosine squared of x. Well, now what's 1 minus cosine squared? That's the sine squared, so this would end up being 2 over the sine squared of x. Well, that means this is going to be 2 cosecant squared of x. So this should simplify into 2 cosecant squared of x. Let's see here. 1 all over the secant of x plus 1 minus 1 all over the secant of x minus 1. Well, we definitely want to get the same denominator, so this would turn into the secant of x minus 1 minus the quantity of the secant of x plus 1 all over the secant of x plus 1 times the secant of x minus 1. The numerator should simplify into negative 2 all over the denominator of the secant squared of x minus 1. Alright, so what is secant squared minus 1? That's just the tangent squared, right? So this would be negative 2 over the tangent squared of x. Well, that would be the same as negative 2 cotangent squared of x. So this should all simplify into negative 2 cotangent squared of x. Some of these identities I know get a bit more obscure after a while, but they are very important for future uses, especially in calculus. Alright, so we have the tangent of x minus the secant squared of x all over the tangent of x. So we definitely want to get the same denominator. Well, this would just turn into the tangent squared of x minus the secant squared of x all over the tangent of x. Alright, so tangent squared plus 1 equals secant squared. That would have to mean tangent squared minus secant squared equals negative 1. So you would just end up getting negative 1 over the tangent of x, which should give you the negative cotangent of x. So in the end, this should simplify into the negative cotangent of x. Alright, so let's see, we have the cosine of x all over 1 plus the sine of x plus 1 plus the sine of x all over the cosine of x. So we definitely want to get the same common denominator. So this is going to end up then being the cosine squared of x plus the quantity of 1 plus sine of x to the second power all over the cosine of x times 1 plus the sine of x. Well, let's expand the numerator. So you'll have the cosine squared of x plus 1 plus 2 sine of x plus sine squared of x all over the cosine of x times 1 plus sine of x. All right, well, what is cosine plus sine? That actually turns into 1, so you'll end up having 1 plus 1 plus 2 sine of x all over the cosine of x times 1 plus sine of x. Well, the numerator would simplify into 2 plus 2 sine of x all over the cosine of x times 1 plus sine of x. Let me get a different black marker. Well, the numerator, you definitely have a common 2 that factors out, so you'll end up with 2 times the quantity of 1 plus the sine of x all over the cosine of x times 1 plus the sine of x. Well, what do you know? Your 1 plus sines of x will factor out. You're just left with 2 over the cosine of x, which we know will simplify one more time into 2 times the secant of x. So your end result for all this should be 2 times the secant of x. What a doozy it was to get there, huh? Alright, so let's see here. I got 4 problems coming up here where you want to rewrite the problem so it's not in fractional form. This is used all the time in calculus. So let's say we have sine squared of y over 1 minus the cosine of y. This one isn't going to be so bad, because the sine squared, isn't that the same thing as 1 minus the cosine squared of y? So now you'll have that over 1 minus the cosine of y, which 1 minus cosine squared factors into 1 plus the cosine of y times 1 minus the cosine of y all over 1 minus the cosine of y. Well, the 1 minus cosine of y's cancel out. This should literally simplify into 1 plus the cosine of y. And these simplification problems in general are very useful in calculus, especially with the integration parts. Okay, now we have 5 over the tangent of x plus the secant of x. So you have this. How are we going to simplify that? Well, you can use a trick that's like rationalizing the denominator. So you're going to multiply the numerator and denominator by the conjugate, which would end up being the tangent of x minus the secant of x. So you would pull the conjugate trick. Alright. So this would turn into 5 times the quantity of the tangent of x minus the secant of x all over the tangent squared of x minus the secant squared of x. Well, what's tangent squared minus secant squared? That would end up being -1, right? So you would end up having -5 times the tangent of x minus the secant of x, which would end up simplifying one more time into 5 times the secant of x minus 5 times the tangent of x. And that would be the best we could do. You would end up getting 5 times the secant of x minus 5 times the tangent of x. Alright, so we have 3 over the secant of x minus the tangent of x. So how are we going to simplify that? Well, we pull the conjugate trick again. Multiply the numerator and denominator by the conjugate. So you multiply both of those by the secant of x plus the tangent of x. So we'll do that. Well, this would turn into 3 times the quantity of the secant of x plus the tangent of x, all over the secant squared of x minus the tangent squared of x. Well, secant squared minus tangent squared equals 1. So this just turns to 1. You'll be simplifying down into 3 times the secant of x plus 3 times the tangent of x. That would be the best you could get. 3 times the secant of x plus 3 times the tangent of x. Alright, let's see. We have the tangent squared of x all over the cosecant of x minus 1. No, I'm sorry, plus 1. Excuse me. It's the cosecant of x plus 1. Well, again, to solve this, you want to probably multiply the numerator and denominator by the conjugate of the denominator. So that would end up being the cosecant of x minus 1 all over the cosecant of x minus 1. So now you'll have the tangent squared of x times the cosecant of x minus 1 all over the cosecant squared of x minus 1. Alright, well, cosecant squared of x minus 1, let's deal with that. We know that 1 plus the cotangent squared equals cosecant, so this would actually turn into the cotangent squared. So this would turn into the tangent squared of x times the cosecant of x minus 1 all over the cotangent squared of x. Well, we can think of this as the tangent squared of x all over the cotangent squared of x, all that times the cosecant of x minus 1. Okay, well, we need to take tangent over cotangent. So this is going to be the same as tangent squared of x all over 1 over tangent squared of x times the cosecant of x minus 1. Well, that would simplify into the tangent of fourth times x, tangent of fourth x times the cosecant of x minus 1. So this would simplify all into the tangent fourth of x times the cosecant of x minus 1. So now we're going to talk about what's called trig substitution. these really come up heavily in calculus. Let's say you have something like the square root of 25 minus x squared. 25 minus x squared. Well, you can use trigonometric substitution to deal with this. So you're given 25 minus x squared, where x equals 5 times the sine of theta. Well, if you put in 5 sine of theta, you'll end up getting 25 minus 25 sine squared of theta. So let's do that. This would turn into 25 minus 25 sine squared of theta, which would break down into the square root of 25 times 1 minus the sine squared of theta. Okay, well, what is this product now? So 1 minus sine squared, that turns out to be cosine squared. So you'd end up getting the square root of 25 cosine squared of theta, which would actually then end up equaling 5 cosine of theta. Okay, well, here's the thing. We need to solve for this in terms of x. So x was equal to 5 sine of theta. That would mean that the sine of theta equals x over 5. So let's see here. You would definitely get 5 cosine of theta, but sine of theta is x over 5, so this would actually end up then being the square root of 25 minus x squared. So this would end up equaling 5 times the square root of 25 minus x squared all over 5, which would turn you back into the square root of 25 minus x squared. So yes, this trigonometric substitution business proves that you can use trigonometric substitution to deal with these in calculus. But for now, we're only worried about the trigonometric solution, the 5 cosine of theta. But when we get into calculus, we will deal with more of these types. They do happen a lot in calculus, more than you think. Let's see, we have now the square root of 64 minus 16x squared. They're going to tell you to make the substitution that x equals 2 times the cosine of theta. So let's put that in. You'll end up getting 64 minus 16. This would be times 4 cosine squared of theta, which would turn into the square root of 64 minus 64 cosine squared of theta, which would turn into the square root of 64 times 1 minus cosine squared of theta. Well, cosine squared of theta turns in 1 minus that turns into sine squared. So you would end up getting the square root of 64 sine squared of theta, which your final solution should end up giving you 8 sine of theta. So this should simplify into 8 times the sine of theta. Alright, let's see. We have the square root of x squared minus 9. where x equals 3 secant of theta. So we make the substitution for x to be 3 secant of theta, so let's put that in. You would end up getting 9 secant squared of theta minus 9 is, well, that's going to equal the square root of 9 times that secant squared of theta minus 1. All right, well, what is the secant squared of theta minus 1? That's the tangent squared. So this would end up being the square root of 9 tangent squared of theta, which should just give you a final answer of 3 times the tangent of theta. So there's your 3 tangent of theta. Alright, we have the square root of 9x squared plus 4. They're going to tell you to make the substitution that 3x equals 2 times the tangent of theta, which would have to then mean that x equals 2/3 of the tangent of theta. So let's go ahead and substitute that value for x in. You should end up getting 9 times, what's 2/3 squared? Well, that would be 4/9. Then times the tangent squared of theta. All that plus 4. Well, 9 divided by 9 is 1. This would just turn into the square root of 4 times the tangent squared of theta plus 4. Well, you would end up with the square root of 4 times the tangent squared of theta plus 1. Well, what is tangent squared plus 1? That's secant squared, so you'll end up getting the square root of 4 secant squared of theta, which should just give you 2 secant of theta as your final answer. So you should end up getting 2 secant of theta out of this. So trig substitution happens all of the time in Calculus 2 and higher. This is just an example with trig substitution, but what would happen in calculus is you would do the trig substitution and then you'd have to go back and find the algebraic equivalent to those, which we aren't going to do today, but we will in calculus. Now I got 4 more. They involve logarithms. We're going to write these as logarithms of a single expression. So let's say you had the logarithm of the cosine of theta minus the logarithm of the sine of theta. Now again, these logarithmic trig identities come up all of the time in calculus. Well, we have a difference of 2 logs. Doesn't that mean the log of one of these divided by the other? So this would turn into the natural log of the cosine of theta all over the sine of theta, which cosine over sine would just turn into the cotangent. So this should just turn into the natural log of the cotangent of theta. And you're probably wondering, why is there an absolute value sign? Well, keep in mind you can't have a negative or 0 value for your logarithm function. So that absolute value ensures that everything stays positive. So these logarithmic trig identities come up all the time in Calculus 2 and higher also. Alright, so we have the natural log of the cosecant of theta plus the natural log of the tangent of theta. Alright. So we have a sum of two logs. This turns into a product rule. So this would be the natural log of the absolute value of the cosecant of theta times the tangent of theta. Well, this would simplify into the natural log of 1 over sine of theta times sine of theta over cosine of theta. Your sines will cancel out, giving you 1 over cosine, which should mean this turns into the natural log of the absolute value of the secant of theta. So that should simplify into the natural log of the secant of theta. Two more of these, then we're done with the lesson. We have the natural log of 1 plus sine of x minus the natural log of the secant of x. Alright, so this is definitely going to be, we have a difference rule which turns this into a quotient rule for logs. So this would be the natural log of 1 plus the sine of x over the secant of x, which the secant is the same as 1 over cosine. So this should turn into the natural log. Why am I doing an absolute value on the natural log? The natural log of the cosine of x times 1 plus the sine of x, which for a final answer should be the natural log of the absolute value of the cosine of x plus the sine of x cosine of x. So that's how that's simplified into a rather hideous one. And then we got just one more. We have the natural log of the cotangent of x plus the natural log of 1 plus tangent squared of x. Alright, so you have a sum of two logs. This turns into a product rule. So this would become the natural log of the cotangent of x times 1 plus tangent squared of x. Well, we can simplify this further. This would be the natural log of the cotangent of x plus the cotangent of x times the tangent squared of x. Well, this is interesting now because this will turn into the natural log of the cotangent of x plus, what is that cotangent of x? Isn't that the same as 1 over tangent of x, then times the tangent squared of x? Well, the tangent in the denominator goes, that'll become a tangent to the first, so this would simplify into the natural log of the cotangent of x plus the tangent of x. And that's exactly what you would get. So this simplifies into the natural log of the cotangent of x plus the tangent of x. Alright, so that's it for this lesson. Next lesson, we're going to verify some trigonometric identities. We're going to pretty much go through one final round of verifying trig identities before we get into trig equations, which will be after that, and then we're going to start learning brand new trig identities. So I hope everyone has a great day. Take care.